Hi everyone, Krishna this side, and I welcome you all to this channel. So let's solve this system design interview question. Design, search, autocomplete, or type ahead. Okay. Any information that I am sharing right over here is highly been taken from this book called System Design Interview by Alex Su. Okay. So yes, I don't have any prior experience about any system design interviews and all. So this for the first time I am considering to make this video. So at any point in time, if you guys feels that I am sharing some wrong information or needs some correction and all, please feel free to give suggestions and all in the comments. I'll be really happy with all those things. Okay. So yeah, what is search autocomplete or type ahead, right? So whenever we search something on Google, at any point in time, if we even simply type any particular character, we notice that we are getting a couple of suggestions right over there. So yes, that is something we call it as a search autocomplete or type ahead. Even on e-commerce website like Amazon or Flipkart, we notice that this type of system is available. So if we try to search any particular keywords and all, we get a couple of suggestions right over there. So those suggestions is something what we will try to build right over here. How we can provide those suggestions and all. That's something we will try to take care in this particular video. Okay. So yes, first thing is like we can collect functional requirements here. So functional requirements, and here we can keep on asking questions to the interviewer. So what are the functional requirements that we will be having? That is something what we have to focus right over here. Okay. So yes, first thing is like we can ask question about um, let me change the font. Whatever the search suggestions that we are providing, right? So how many suggestions we really want to provide? That is the first question, right? Like how many suggestions do we need to provide? Okay. So let us suppose the interviewer says that like 10 sessions we are basically providing it. So yes, 10 is the answer that we got. Now, uh, how this particular system knows that which top 10 sessions we need to provide, right? So that is the second question, right? So how the system knows which top 10 suggestions we need to provide. Okay. So we get the answer like whatever the popularity or based on the frequency on all frequency about that particular word. Based on that, we have to collect those words, top 10 suggestions that are there, and those suggestions we need to provide based on ascending order, or I mean based on the popularity and all. We have to provide the results. Okay, that is something what the answer we may get at this point in time. So next question is like. Are the search queries basically in English or any other languages? That is the next question. Are the queries that we are searching, queries are in English or other languages, okay? Or other languages. Let's for this point in time, let's suppose we get the answer like only English is something what we are supporting with the time. If time is left out, we can discuss about other languages as well. Okay, that is something what we get the answer right at this point in time. Okay. Uh, Now, lastly, we can ask like how many daily active users basically using this product? How many daily active users we have? Okay, let's suppose 100 million users basically using this product. So that is the answer that we got it at this point in time. Okay, so far so good. Now let's discuss about non-functional requirements. Non functional requirements. Okay, so here in non-functional requirements, right? So first thing is like obviously here we will discuss about how the system should be basically whether it is going to be scalable, or do we really require to provide the consistency, availability, and all those things we can basically consider in non-functional requirements. Okay, so yes, we have to take care of cap theorem and all while considering this designing the system. Okay, the first thing that comes in our mind is like whatever the response that we are providing to user, it should be really fast enough, right? Because if let us suppose user typing something, and we are trying to send a response, but user typed next word as well. Now after user typing next word, we actually send a response. So obviously this is not something what we want to build, right? So the moment user types something, system should be so fast and quick that it should immediately send a response to the user. So yes, obviously the response should be really fast. Okay, the response should be fast. Ideally it should be like in between the 10 millisecond, okay, millisecond to, let's suppose 60 millisecond. Okay, in between this particular time only the response should be there. Okay, now next is like if we discuss about the cap theorem and all, here we are not bothering about the consistency, right? Like we have three things in the cap theorem. So the first thing is consistency, second is availability, and last one is partition tolerance. So obviously we cannot consider all three factors at same point in time. We have to pick two of them out of these three things. Okay, so here we are not bothering about the consistency because we don't want to send error response if there is some failure, or we may not have updated response, and we want to wait users to let the response get updated first, and then we want to send the response, right? That is something what we don't want to perform right over here. So obviously here the availability is really necessary, and second is like partition tolerance. Obviously we will be having 100 million users daily using them, so it should be divided, the data should be divided on multiple servers. Okay, so yes, here the main concern is like availability and scalable. These are the two things we are really bothering about. So second is like availability. Okay, so it should be highly available, system should be highly available and scalable. Okay, so these are few of the things that we have collected so far. Now let's try to design the system. Okay, so before that we'll discuss about the QPS, that is like queries per second. How many queries we are getting it per second basis, right? So 100 million users we have. So 100 into 10 to the power of 6 probably, that is the number of daily active users we have. And let us suppose a particular user basically using our system 10 times a day. Okay, so 10 times he's basically using it, and each time whenever he type any particular character, right? That is actually our request, particularly we can say that, right? So the moment user type any particular character, we are basically going to our servers, and we are trying to collect words, and we are sending it back to the user. Okay, so let us suppose user typed 5 words every time, and each word probably have 4 characters length. So 5 cross 20 is like 20 queries user making every time. Okay, in total 20 queries user making, and 10 times he is basically using the system. Okay, so that is like these many requests on an average daily we were getting at any point in time. Okay, so now if we try to divide it with 24 cross 3600. Okay, so in 24 hours these many requests we are getting it. So per second basis how many requests we are getting it, that is something what we are trying to calculate here. So probably I just remember this particular value, like 24 cross 3600 is basically let me just write down right over here, instead of here 24 cross 3600, it is around like 86400. Okay, that is the value that we get it basically. Okay, so you can remember it like 86400. Okay, ideally I'm not sure like how important is QPS calculation and all, but yes, probably we should have idea about it. Doesn't matter if interviewer are really interested in this one or not. If they say like we can skip this, we can probably skip this one as well. Okay, but yes, if required, if interviewer asks like just want me to he actually wanted to get this QPS and all, obviously we have to some idea about this as well. Okay, now when we try to perform the operations here, it is like this particular zero, this zero, and these two zeros got cancelled out, and the moment I try to divide this 2 and 100, it is like 200 divided by this 864, average value is basically going to be 4. So 10 to the power of it is like okay, it is like 10 to the power of 6 divided by 4. Okay, I can probably write it like 100 into 10 to the power of 4 divided by 4. Okay, so when we try to divide this whatever this 100 divided by 4, right? So we get 25 into 10 to the power of 4. It is approximately equals to 2,50,000. Like it is like 250k queries we are getting it on an average. Okay, so yes, 250k queries we are getting it per second basis, and during the peak time, let us suppose we have some on particular day it the queries got peaked, so we can multiply it with 2 times that, like it is going to be 500k request we are getting it on per day basis, per second basis. Okay, now that we calculated the QPS, let's try to design this type-ahead autocomplete system. Let us suppose these are the users who are actually making the request. So user 1, user 2, and all. So we will be having multiple users. Okay, so before this the moment user type any particular word, it is going to be a service. So we have to have here something called as load balancer. Okay, whenever user make any request, right, so the moment user types something, it will be a request. So obviously, before going directly on the service, we will be having load balancer. So here we can say that rate limiting, authentication, everything will be there. Authentication, next is like rate limiting, all those logics will be there. Okay, why we need rate limiting at all? Obviously we require rate limiting, we don't want to overload request from a particular user, so rate limiting should be there. Next is like yes, load balancing or all those things will be there. So this is like kind of middleware. So let me change the color of this particular one. Okay, so we got middleware. Now next is like we will be having two different services right over here, right? The first one is whenever user types something, it is basically a query. So the first service is basically a query service. Okay, so this is our query service, and we are basically here whatever the servers that we are using it, right, to whenever user makes any queries, the load balancer basically balances sends the query on servers. So we, of course, we have to use here multiple servers. So whatever the services that we will be having, the query service, it should be horizontally scaled, so that we don't want to make bombard multiple users on particular single server, right? So we can use any particular algorithm from the load balancer to balance the load across all the servers. So this is our query service. Okay, now since it is horizontal, it is scaled, there shouldn't be any issue with multiple amount of users who are basically making any queries. And second service is basically uh, obviously it is since we are actually gathering the information as well, right? So at any point in time, whenever user searches any particular words or sentences, that particular information is something what we want to store somewhere, and based on that information only we want to uh, uh, build our database, and we want to store information in such way that whatever the particular words and all those searched most frequently, those particular words has been searched, those information we will keep on collecting and we will keep on updating it. So this is like data gathering service, and this particular API should be of course hidden from the users. Okay, we don't want to expose these APIs to the users. Okay, so this one is like data gathering service. Okay, right. Now let's first discuss about this query service. Whenever user types something, okay, so this is our request. So yeah, this is our search query result. So whenever user type, let's suppose T is something what user typed. So this is the API that is basically, this is the query that we want to basically search. Okay. So based on this T, we have to collect, get it from the database, the information from the database, and we have to provide the top 5 suggestions or 10 suggestions based on whatever the user basically uh, on demand, whatever the system we set, like how many suggestions we want to basically provide to user, those many information we can provide it back to the user. Okay, so this is our API. Okay, the moment user types something like T or something like that, so it goes to our query services, and from query service simply we will be having here database. Okay, initially let us just discuss about this. So this is our DB. From DB we can get the information. So let me fill this color as something else. This is our DB. In this particular DB, we will be having all the information, like how many times particular word has been searched and all. So we'll basically collect that information and we'll return back to the user. So all the top 5 suggestions or 10 suggestions that are available based on the requirements, we can get it from here, from the database. We will provide back to this query service, and from here it goes back to the user. Okay, so this perfectly fine at a small scale, but at large scale, obviously we have to consider what database we have to use, and obviously we cannot simply rely on database only. We should have here in between something between this database and query service, we should have caching service. Okay, so we should have caching layer. Based on that, the moment user searches for something, instead of going back to the database and collect the result from the cache itself, we will collect the information and provide it back to the user. Okay, so yes, so obviously in between this query service and this database, we should have here caching. Okay, so this is our caching. And this will be like it could be memcached or redis, something like that. So we have cache layer. Okay, so before directly going back to the DB, we'll go and check if the query is available uh, in this particular cache, if top 5 suggestions available for that particular query. If so, we will get that and we will provide back to the user. Okay. Now here obviously this cache and DB needs to be highly available and scalable, because and single on particular single server we cannot store all the information, right? So obviously we need to have multiple database instances across which we can store the information and we can collect them and we can provide it back to the user. So of course the first thing that comes in our mind is like we will shard this database and we'll store the information. Okay, so before talking about the sharding and all, scalability and all, let's try to discuss about which particular database we can use right over here, right? Because that is the most important thing to solve this particular question. Okay, so now see, if we try to use a simple relational database, obviously, if we try to get top 10 suggestions from the database, it is not going to give us the optimal throughput that we are actually looking out for. Okay, so obviously, what we have to do is we either can use NoSQL like MongoDB and all to serialize the information that we are gathering from here, and we can store their frequencies and all with a particular keywords and all. Or else what we can do is we can use right over here try data structure. Okay, and I already covered it try data structure in one of video, how we can build this try data structure and all. You can watch the video, I'll provide the link in the comment. Or else like instead of using this MongoDB, we can rely on the try data structure. So it is really fast enough to get any particular words available in this try data structure, and we can provide it back to the user. Okay, so how try data structure looks like? So the idea is here, what we can do is let us suppose we have a root level. Okay, here root level is there, and the moment user types something at each level, okay, at each level we will be having 26 instances of this particular one. Okay, since we are just storing lowercase characters, I'm just considering that, so I'm saying like 26 try instances will be there at each level. Okay, and I would say that at root level 26 characters we are storing it instances of tries data structure. Okay, so here the first is like it will be from here the next any particular character that is there, like it is a. Okay, that is also another try. Okay, so at this particular a also we will be having 26 instances of tries. Okay, and from this again let us say that we have b. Okay, then next is like c, so on, this goes all the way to z. Okay, so we will be having these 26 characters instances available at each level. Okay, at this a also we will be having again 26 instances of the tries. Again at this b also we will be having 26 instances of this b, sorry, tries instances, and at last like for the c also we will be having 26 letters. Okay, again like it completely depends, like if we are having different characters as characters that are there, it is not just simply this lower end characters. We have to probably use hash map to store all the pairing values. Okay, instances of this one. Okay, so just generally in this particular one, just consider that we are just having only characters, so we can store 26 instances at each level. Okay, now again for this a we will be having 26 instances. Okay, so it is like again starting from a. Okay, next is like b, same thing. Okay, uh, and lastly like it is going to be c and z. Last is like let's suppose z is the character that we have. Okay, so a b c all the way to z. Okay, these available at all these characters. Okay, what are the try instance that we are having here? So at each of them we will be having these 26 instances of these tries. Okay, going again same thing will be there. So now this way, like at any point in time, let us suppose user searched for t. Okay, or let us suppose user searched for b. Okay, what I'll do is I'll just update for the b. Okay, this is how the small try data structure basically looks like. So at each level I already explained you, like we will be having 26 characters try instances. Again for this one also it will be same again at each level. Okay, we will be having those 26 instances. Now simply we got some information like at this B we have BAT, that is complete word. So at any point in time, if particular word has been complete, what we can do is we can from this data gathering service, we basically can collect how many times this particular complete word has been frequently appeared. Okay, so let us suppose bat is has been appeared 20k times. Okay, 20 times I would say, like instead of 20k. So 20 times this particular word has been appeared. Then next word is like BALL, ball has been appeared, let us suppose 25 times. Next is like BASE, base has been appeared 15 times. Last is like BEST, best has been appeared like for 40 times. And BELT, this appeared 10 times. Okay, so let us suppose we are basically trying to pick top three suggestions from here. Okay, so the moment user type B, okay, so what we can do is we can go and we will keep on following this particular from B. We'll go downside and we'll collect top four characters. Okay, for top four words that are there which has been appeared more frequently. Okay, as in their frequency is something what we have stored. So we will go at this one, we will simply use DFS techniques to keep on calling this one, and we'll go downside and we'll keep on searching like which are best words, frequently used words that are there. Those words we will pick it and we will pull it and we will send it back to the user. But again, if we discuss about this one, this particular approach that we are trying to use, this BFS, it is pretty much slow, considering like we will be having millions of keywords that are there, these characters and all. So if we try to go every time and we try to collect that information and get it and send it back to the user, it is really hectic and problematic thing, right? So what we can do is we will use hash map here in this particular one. So at each particular level, okay, whenever user type the B, there itself we will pre-compute these values. Okay, so what are top 10 words that are there which are actually most frequently used, their frequency has been used. Okay, those words only we will get it directly and we will store at each character. Okay, so at this particular one B, let us suppose top four characters which are there, right? So whenever user type B, so top four characters are like 20, 25 and 40 and 15. These top these words are there, right? Like that. Next is second one is sorry, this in the, if I discuss about this one in shorter order, so it is like BEST. Then next one is like BALL. Next is like BAT, and probably last one is like BASE. Okay, so these are top four words that are there available at this particular one. So those four words we can store at each level. Okay, so at this particular one, let me just remove these things. Okay, at this B, we stored all these characters. Okay, now the moment user typed, so these suggestions we can, the moment user types something, we can get these suggestions. So at this particular level, we will be storing this information, and these words is something what we can get it and we can share it back, send it back to the user. Okay, so this same thing will be available at the cache level as well. The moment user type something, we will get it and we'll send it back to the user. Okay, next is like the moment user type BE. Okay, so we will be at this particular level. So at this one also we will get their frequencies, what are top four or 10 sessions that are there, and those will be available at this one. So here at this one is like BE EST. Next is like BE like that. So all the sessions that are there top, those will be available at each character level. Okay, so at each level we will be having them, and based on that we can get the information and we can easily send it back to the user. Okay, that's how we can store this information at this one. Okay, so simple idea is like we will be having try data structure. We will be using here try try in the sense like we will be storing this information at in form of we will construct a try data structure and we will store that information. Okay, so it is like a try something what I'll just name it as. Okay, now since this information is what we have stored, now at the cache level also this information, similar kind of information will be available, and it is something what we can get it and we can send it back to the user. Okay, but if we try to store all these at same single machine, okay, there will be problem, like because the data can be pretty much huge, and a single server cannot hold that much of huge amount of information. Okay, considering like Google and all these services are running from very long time, right? So obviously a single server cannot handle all those different words that are there and all. Right, what we can do is we can shard this information. Okay, so how we can shard it, basically so whatever the characters that we have, let us suppose at root level we have A, B, C all the way to Z. So we can, what we can do is we can maintain 26 different databases, okay, try databases, 26 different DBs is something what we can maintain right over here. So we will be sharding this information based on the characters, okay. The moment user type A, we have to take user at that particular appropriate DB where the A is actually available, okay. Same logic will be available at the cache level as well. The moment user type A, the information should get redirected to the database which is basically storing all the words that basically starts with A, okay. So that way we can split this DB, okay. But again, let us suppose if still this particular information is not highly scalable, then what we can do is we will be maintaining this, let us suppose AA to AB, this particular information will be available in one particular DB. Now from AC to, let us suppose, AD, this will be available in another DB, okay. This way we can keep on sharding this information, okay. And the moment user types something like AA or AB, something like that, we will easily can redirect that user into that particular DB, okay. So from AA to AB, any particular characters or words user type, basically we can redirect him in that particular database, okay. So to store this information like AA, AB, what we can do is on the query service itself, like we can maintain some sort of config file on all these different servers that are services that are available, that are basically running. So it is like on each services we will be having a same kind of config file which basically tells the users that on which particular DB, sharded DB, user needs to be redirected and get the information. Or else we can maintain external services like Zookeeper and all, Zookeeper or console, something like that, and we will maintain same kind of config files and all on that particular one, and from there we can get the information, okay. So yes, that is something about scalability issue. It basically can solve that scalability issue, okay. Now that we are done, like we basically sharded the information and we scaled out our system and all. So at any point in time, whenever user searches anything, it basically tells like on which particular sharded information that is there, cached layer and all, where the user basically needs to be go and collect the information. And there also we already optimized this tree data structure and all. So we will be storing pre-computed frequently used words at each tree level, okay, try level, okay, whatever the instances that we have, these characters and all. And there, from there we can get the information and we can send it back to the user, okay. So I guess this is pretty much about the query service. And now talking about the data gathering service, right? So here what we can do is we can simply maintain log files. So whatever the logs that basically we are collecting at any point in time, whenever user searches some words, okay, what we can do is we will log that information. So first is like we will be logging that information, okay. So here we are keep on logging that information. So let us suppose this log is basically kind of at 12 o'clock. Let us suppose tree is something what user has been searched at 12, and this is the time, okay. And the frequency of this particular tree at that particular time is like, let us suppose, 100 times this particular word has been searched, okay. This way we will keep on logging the information. So apple is next word that has been there at 12:04. At this point in time, apple has been searched 200 times, like that, okay. This way this logs basically collects the information, and we will keep on storing it, this kind of logs in this particular one, okay. Now what we can do is whatever the logs that we have, there will be a huge amount of logs we will be having it, right? So obviously we need to aggregate this information, because at let us suppose at the next point in time, again around 1:30 and all, this particular tree has been searched at around 13 or 14. So at this point in time, again this has been searched. So yes, similar kind of words or something like that, it has been basically keep on getting searched. So this information needs to be properly aggregated, and then only we have to update the try db, okay. So what we can do is here we will be having whatever the logs that we collected, right? So we will be having next is like data aggregating service, okay, data aggregators. So here we will be having aggregators. So let me just change the colors of these things. Next is like aggregating service is something what we have. So this aggregator service, basically whatever the logs we have, right? So we will keep on aggregating them. So it completely depends now based on the information that we basically required, how frequently we want to update this try db and all. Based on that, we will be writing this code in this one, okay, in this aggregator service. So at any point in time, if we really want frequently update this data, so this aggregator service should collect the information in most recent time, and based on that time interval, it will keep on adding this information, like how many times a particular word has been appeared. Okay, the moment this is been done, so we will keep on storing them into this aggregated data. So whatever the data that has been aggregated, we will store them somewhere. Here we will be having aggregated data. Okay, so this is like all the data that we have, we are actually storing it right over here. Okay, uh, and next is let me just put it downside. Okay, so yes, now the idea is how frequently this data needs to be updated, right? So at any point in time, if we look into this particular Google and all, right, so I don't think like they really update this DB very frequently, because it will be really affecting on this query services, because yeah, at any point in time, if real time information, that is something what we want to provide right over here, so we will keep on updating it, and query service may try to get the information. So there should be some performance impact and all. So obviously we can have schedulers or something like that on weekly basis, or depending on the time duration, how frequently we want to update the data, we will be having some schedulers here. So there is like schedulers, so we will be running bunch of schedulers right over here. So the job of this particular schedulers is they will be collecting this data from these aggregators, and they will update this triad AB. So at any point in time, there are multiple snapshots running. So we will keep on updating it into that snapshots, and whatever the new snapshot that is there, that information we will again update into this cache layer as well. So here we will be running schedulers. So yes, let me create there all these schedulers that we have, right? So it is like okay, so these are our schedulers whose job is basically to update this IDB. Okay, I think this is fine. Like this is how we can basically uh, design this particular search engine. Okay, not search engine, sorry, type ahead or autocomplete. Okay, I guess this is fine. Now, slight optimizations with this query services. The first thing is whenever user make any request, right? So we don't want to refresh the entire web page, right? So for that, what we can do is we can use Ajax request. Okay. Basically, they does not refresh the entire page. Okay. So whatever the whole page that we have, whenever we make request through Ajax request, it is basically much beneficial for us. Okay, and next is like the second option is like we will use browser caching. Okay, right over here. So how this browser caching basically used is like see this any information that is available on this servers, they may not get changed very frequently. So obviously we can store those results, so whatever the user has been searched and all into this browser cache, those results we can store them. So at any point in time, whenever user searches something directly from the browser itself, we can provide the information back to the user. Okay, so yes, those are a couple of few sessions we can provide at the end, and yeah, this is how the entire application may looks like, the entire system design. Okay, so yeah, if you see that if there are some issues or some information that needs to be corrected at any point in time, please make sure to suggest or give comments. Okay, it will be really thankful again. Okay, so yeah, that's all from this particular. Thank you for watching this one. Bye bye.